Hi everyone, it's Mr. Hutton here for our second instalment of our kit car project. Now let's just refresh ourselves. We're making a kit car. It's a working car. A kid flicks a switch, the car roars into life and whizzes along the pavement. That's what we're looking for, okay? It's going to be sold as a kit, so some parts are already made, some parts the kid has to do themselves. So imagine that in a box. That's effectively what we're doing. There will be a lot of design to this project, that you have to come up with your own design and your own thinking and etc. But a lot of it is going through methodically and making sure that things are working and we are being as accurate as possible. So the scenario is that a company wants to diversify away from the whole idea of just something plastic in a box. Plastic's not very sustainable. Other more sustainable materials are, can I reuse something again, or can I repurpose something, or can I use something that's more sustainable like wood? So those are the direction the world is going in, and we've got to keep on top of that. So have a read through this sheet again, familiarise yourself, and what we're going to do is we're going to move on today through the tools and the production process. You should know what you're doing now. You're making the chassis. The chassis is the main part of the car, the main part of the car where things are bolted onto. In real life, that's what happens. A very strong steel frame is made and things are bolted onto it, and that's the way the car works. Now, next we're going to talk about this guy here. This guy is a guy called Elon Musk. He's a billionaire. He's got a lot of money. He made his money through really technical companies, and he started putting his energy and money into another company called Tesla, which are making top-end American cars. Most of the cars are made in America in these huge factories called gigafactories, and very interesting, really interesting. All the cars are electric, all the cars are recyclable, so when a car's finished with, you could probably take 90% of the car and reuse it again for something else. So I've got a really interesting little film for you to watch about how the cars are made, and they take raw materials like aluminium and other parts and make the car in one factory, which is amazing, absolutely amazing. So have a look at the film, and then we'll move on to the next task. So hopefully you've looked at that film and you've had a look at how Tesla works. It's a really interesting idea, but you should have seen the robots putting the parts onto the chassis and all the automation that's used in that factory. And we need to kind of get in our heads that same idea of making things as good as we can. Imagine your toy is being made by a robot. It would be superb, and that's what you're aiming for. Now, interesting that Elon Musk chose the name Tesla for his brand of electric cars. If you don't know why, you need to Google that and find out, because there's a whole load of history there about Nikola Tesla. You need to know about these things. But today, ironically, we're going to be looking at electricity. Now, we're making a kit car that's going to move, and to make it move, we need a motor. We're going to be using a 9-volt motor, and that's going to provide a lot of power. 9 volts doesn't seem a lot, but it's a lot to do the job. You know, this car could work even with a 3-volt motor, but we've got 9 volts, a lot of power. If we can harness that power and make it work, we're going to make this car really whiz down the pavement. So we have a motor. You need to understand how motors work, and there's a little bit of information here. It's an output device. In other words, it does something. We need to also have some kind of control for the motor, so we're going to have a simple switch. That's an input control device. We're controlling what's going on, and we also have some kind of power. Now, when you're putting this together in the classroom, you won't use a battery. I've used batteries before, and they are terrible. They just run out and they go in the bin, and it's really environmentally very bad. So we're going to use, I bought in a direct current power unit. So there's going to be 2 in the classrooms. I might buy another one as well, but I might do it. There might be 3. And what you'll do is you'll connect the direct current to your motor, and that will give you the power. So you can do all the testing of your chassis, of the motor, the switches, the cables, etc., using the DC power pack. And then when it all works, you can use a battery when we take them outside to do the final testing. much more efficient, much better, and you know it works. You know it works. It's not, oh, is this dodgy battery? This is battery dead. Don't know, etc., etc. Much easier. Just use the power supply, direct current. Now, where does electricity come from? You should know this. There's a lot of overlap with science, etc. But let's get ourselves in the flavour of what is alternating current coming from a plug, what is direct current coming from a battery, what's the difference, etc. So we know what's going on. So spend 10 minutes reading through and answering the questions here. Okay, it does say on the sheet it's a 6-volt battery, it's a 9-volt battery, it's a 9-volt battery, not 6-volt. A lot of people got confused with that last time with the question. It is a 9-volt battery. But what would happen if we put a 6-volt battery in? What would happen? You tell me. So go through the sheet and join us for the final task. Now, on this final task, if you don't have time to do this, I don't mind. I'm trying to give you as much work as you can get. But we need to be thinking about market pull and technology push. Now, every product is pushed and pulled by various things in society. Market pull really is referring to the new design. Now, the best example is your mobile phone. You know, everybody wants the latest version of the iPhone or whatever it might be, your Samsung or your Sony, the latest version. And that is, people want improvements. They want improvement in battery life. They want improvement in features. They want to, you know, make sure it lasts for ages, etc., etc. So that's what people want, and that is the pull of the market, And every company is competing to have the latest gadget and gizmo. If you think about the example of cars, people are doing the same now. A car will get you from, you know, here to school, no problem, whatever car you get. But hey, I'm not interested in that. I want a car that does this. I want a car with Wi-Fi. I want a car that drives itself. I want this. I want heated seats, or whatever it might be. That is the pull. And so whatever's happening now will trickle down to cars that are cheaper. So what's happening at Tesla, for example, is at the top end of the market, and that will filter down to the other cars as it goes. And that's the pull. That's the pull of the market. The second thing is the technology push. Now, that is the development of new designs all the way through. So it may mean that there was a problem with the technology before, or it wasn't very good. So all, you know, as well as the market pulling things along, there is a push from the technology of things getting better, things getting more efficient, things getting lighter, things getting made of different materials. And that's the technology. So the technical parts that are improvements are just pushing it along all the way through. Finally, on this sheet is demand. You want to create a demand. You want to have a product that people need and want. And you also need to return a profit. Now, the criticism of Tesla cars at the moment is they are so expensive. They are not designed for the everyday user. They're designed for the top end market. So you need to have a product that is high demand, you know, that everybody wants, and is going to give you a high profit margin. You know, if you have low demand with a low profit margin, your business will fold. So have a look at this. It's really important, and fill out the questions on the sheet. Okay, cheers. So there we go. Hopefully this lesson you've learned a lot more about Tesla, learned a lot more how about cars are put together, and hopefully now we're ready to kind of move into the next stages of our project, hopefully as practical as possible. Okay, so keep the communication going. If you have any problems, contact me on Teams, ask me any questions you need, send me your work, take a picture of it, etc. You know, keep the lines of communication going. I hope you're well, I hope you're safe, and I'll see you soon.